Hello everyone and welcome to all of you. Today's lecture on test of significance. In this lecture we will discuss hypothesis, critical region, label of significance, decision error and degree of freedom. Dear students, we have already discussed statistics are two types. First is descriptive statistics and second is inferential statistics. In the inferential statistics, there are mainly two functions of statistics are theory of estimation and test of significance. In the theory of estimation, we estimate the population parameter by the statistics. Okay, dear students, suppose parameter mean mu is 20 and our sample mean is 19.5. So we can say that this is something equal to the population mean. Our sample mean something equal to the population mean. There are only 0.5 difference. Okay. Now, but in this situation, our mind make a hypothesis. Maybe population and sample mean are equal or not equal. Another situation, many experimental work, estimation of the numerical value of a parameter will not be direct interested to us. Instead, we may be interested in making decision about population on the basis of sample information. For example, a variety of paddy will give better yield than the running variety, and a particular crop management method will result in better yield of a crop, etc. For this, we need a statistical test to support such decision because result of experiment are usually not clear cut. Okay. So in this situation, we use the test of significance. So in the test of significance, we use some terminology and we discuss one by one. Dear students, the main problem in statistical inference can be broadly classified in the two areas. First, the area of estimation of population parameter, and second is test of statistical hypothesis. What is hypothesis? A hypothesis is a claim about one or more population parameter. Dear students, hypotheses are different types. Okay, simple hypothesis, composite hypothesis, scientific hypothesis, and statistical hypothesis. So here we only discuss statistical hypothesis. A statistical hypothesis is some statement or assertion about a population or equivalently about the probability distribution characterization a population which we want to verify on the basis of information available from a sample. Okay, is known as statistical hypothesis. Statistical hypotheses are classified in two types, that is simple and composite hypothesis. When a hypothesis specifies all the parameters of a probability distribution is known as simple hypothesis. All parameter means that, all parameter means mu and sigma, where mu equal to 0 and sigma equal to 1. It is belong to normal distribution. Okay. If the hypothesis specify only some of the parameters of a probability distribution is known as composite hypothesis. Some parameter means mu or sigma. There are only one. Okay, maybe mu, maybe sigma. Okay. Now, test of statistical hypothesis. A A test of statistical hypothesis is a two-action decision problem. After the experimental sample values have been obtained, the two action being the acceptance or rejection of the hypothesis under the consideration. Now, null hypothesis. What is a null hypothesis? A definite statement about the population parameter. Such a hypothesis, which is usually a hypothesis of no difference, is called as null hypothesis, and it is denoted by H0, H0 also. Okay. Example of null hypothesis. First is the observed mean is not significant, means that there are population mean mu is equal to the sample mean. Second example, there is no significant difference between the two sample mean. If we derive, in this condition, if we derive two sample from one population, so this situation, there is no significant difference between the two sample means, that is mu1 equal to mu2. Mu1 is the sample first, mu2 equal to sample second. Okay. What is alternative hypothesis? Any hypothesis which is complementary of null hypothesis is called as alternative hypothesis, usually denoted by H1. For example, H1, the observed mean is significant. It means that there are the difference between population mean and sample mean. Okay, so this is not equal, that is mu does not equal to mu0. Here what is critical region? The region of rejection of H0 when H0 is true is that region of the outcome set where H0 is rejected if the sample point falls in that region, and it is called critical region. Dear students, one second. Suppose this point is critical point. Okay, if our sample mean and our sample values fell in this region, this is the critical region, and this is the acceptance region. Okay, 95% area of normal distribution is the acceptance region, and our values of statistic comes greater than 1.96, maybe 1.97 and 1.98. So this is the rejection region. Okay, now decision error. What is the decision? The decision to accept or reject the null hypothesis is made on the basis of the information supplied by the observed sample observation. The conclusion drawn on the basis of a particular sample may not always be true in the respect of the population. The four possible situations that arise in any test procedure are given in the following table. There are some problems with typing. Dear students, suppose when H0 and null hypothesis is true, and reject null hypothesis when it is true is called as type first error. Okay, what is type first error? When reject null hypothesis when it is true, called as type first error. Okay, if we accept the null hypothesis when it is true, called as correct decision. It is the correct decision. Okay. This is the correct decision. If we accept a null hypothesis when it is true, it is the correct decision. When reject the null hypothesis when it is false. This is the correct decision. If we reject the null hypothesis when it is false, it is the correct decision. And accept the null hypothesis when it is false, it is the wrong decision, and it is the type second error. Okay. This called as alpha, and this called as 1 minus alpha. The correct decision value probability is 1 minus alpha, and the correct decision of type first error called as alpha. And here the correct decision of in this situation 1 minus beta. One second. The correct decision in this situation 1 minus beta, and here only beta. Okay. Now from the above table, it is obvious that in testing problem we are available two types of error: type first error and type second error. Type first error, the error of rejecting H naught when H naught is true, called as type first error. The probability of type first error is denoted by alpha. Alpha, what is alpha? Alpha is the probability of type first error. Okay. Type second error, the error of accepting H0 or H0 when H0 is false, it is called second error. Okay. The probability of type second error is denoted by beta. Beta is the probability of type second error. Now, level of significance. What is the level of significance? The probability that the statistic will fail in the critical region is alpha by 2. Alpha by 2. What is alpha by 2? Look here. Dear student, this is one-sided error. This is the alpha by 2. Okay, and this is alpha by 2. If we add alpha by 2 plus alpha by 2 is equal to alpha. Okay, this alpha is the type first error. It is the critical region. Okay. Now this alpha is the nothing but the probability of committing type first error. Technically, the probability of committing type first error is known as the level of significance. It is also called the size of the critical region. Level of significance also called the size of the critical region. Okay, and it is also called the probability of type first error. Okay, level of significance also called the probability of type first error. Now, what is power of the test? This is 1 minus beta. Okay, 1 minus beta is called the power function of the test hypothesis H0 against the alternative hypothesis H1. The value of the power function at a parameter point is called the power of the test at the point. Okay. Now, what is degree of freedom? The number of degree of freedom is the number of observations that are free to vary after certain restrictions we have been placed on the data. If there are an observation in the sample, for each restriction imposed upon the original observation, the number of degree of freedom is reduced by the reduced by 1. Suppose here the total number of observation are n. Okay, here the total number of observation n, and the degree of freedom called as n minus 1. If there are two observation, then the degree of freedom is 1. Okay, 2 minus 1 is equal to 1. If our n is 10, then the degree of freedom is 9. Okay. Now, the steps in testing of hypothesis. The process of testing a hypothesis involves many steps. There are, first step is formulation of null and alternative hypothesis. Second step is specification of the level of significance. In the agriculture, the level of significance is maybe 5%, mostly 5%, and some type of observation is first percent, 1%. Okay. Third is selection of the test, statistic and its communication. Maybe Z test, maybe T test, maybe F test. Okay. Fourth step is finding out the critical value from the table using the label of significance, sampling distribution and its degree of freedom. 5 is determination of the significance of the test statistics. 6 is decision about the null hypothesis based on the significance of the test statistic. Okay. Or last is writing the conclusion in such a way that it answers the question on hand. Okay, dear student, thank you.